So welcome to lesson number 3. We're going to be looking at addition and subtraction of rational expressions. We're going to begin by just taking a review of how we actually add or subtract a fraction. So if I'm looking at the addition of fractions, 2/3 plus 2/5, recall that in order to actually add these, we need to have a lowest common denominator. And so here my denominators are 3 and 5. My lowest common denominator between them is going to be 15. So if I multiply 2/3 by 5 and 2/5 by 3, then I'll have my lowest common denominator, which doesn't actually change the value of my fraction. It just makes it a larger fraction. So we have 10/15 plus 6/15, which if we were to combine those, we would end up with 16/15. Subtracting fractions works the same way. We need to find a lowest common multiple. And in order to do that, lowest common denominator, in order to do that, we have to do the same thing, find a number that both 6 and 4 are multiples of. So in this case, we have 12. The lowest one is 12. So 5 and 6 I would multiply by 2, and 1 and 4 I would multiply by 3, leaving me with 10/12 subtract 3/12, which would ultimately simplify to 7/12. Adding and subtraction with non-variable denominators works the same way. We again need to find a lowest common denominator. So if I look at class example 2b, 3a minus 1 over 3 plus 4a plus 5 over 6, I gotta find my lowest common denominator, which is gonna be 6. So I'd have to multiply the top and the bottom by 2 here. So if I multiply 2 into 3a minus 1, this is gonna leave me with 6a minus 2 over 6 plus 4a plus 5 over 6. It's easiest to rewrite an expression like this as 6a minus 2 plus 4a plus 5 all over 6. Because when we go to simplify this, what we'll be left with is 6a and 4a, which would be 10a, negative 2 and positive 5, which would be positive 3, over 6. And then we would have an expression that can no longer be simplified. I've done example 3a for you, and I'm going to do example 3b as well. So we're taking the same approach. In this case, we're subtracting 4 minus y minus 4 over 9 minus 5 minus 3y over 3. And one way to approach these is to remember that if I have a constant term like this is 4 over 1, and that is helpful in creating a fraction with a lowest common denominator. So between 9 and 3, my lowest common denominator is 18. And so I'm going to have to multiply everything here by whatever I need to make, or sorry, not 18, is 9. So I'll have to multiply everything here by whatever factor I need in order to create my lowest common denominator. So with my 1, I'm going to have to multiply this by 9 on the bottom as well as on the top. And with everything here, I'm going to have to multiply by 3 to find my lowest common denominator of 9. So this is going to leave me with 36 over 9, subtract y minus 4 over 9, subtract 15 minus 9y over 9. And at this point, I can combine everything up top. So 36 minus y minus 4 minus 15 minus 9y over 9. And then as I distribute my negative sign into my brackets, I can simplify as well. So what I'm going to be left with is 36 minus y plus 4 minus 15 plus 9y all over 9. And on simplifying, I'm going to have 36 plus 4, which is 40, minus 15, which is 25. So I have 25, and I have 25 plus 8y over 9. So now we're going to look at the addition and subtraction with common denominators. Now in this case, my denominators are the same, even though they're all variables, but it's actually easier because I can just combine these into one denominator. So that's going to end up being 2 plus 7 minus 1 all over x. So 2 plus 7 is 9 minus 1 is 8 over x. And we also want to state the non-permissible values. And in this case, x can't equal 0. If we look at this one over here, 3y over 3y minus 1 over 3y minus 1, we're going to be left with 3y minus 1 over 3y minus 1. And those will cancel out, and we're just left with 1, in which case y can't equal 1/3. Now in this last example, 4x plus 10 minus 2x plus 4 all over x plus 3, we're going to be left with 4x minus 2x is 2x. 10 minus a positive 4 is 10 minus 4 is going to be 2x plus 6 over x plus 3. Now we can simplify this by factoring the 2 out of the 2x and the 6. So we're going to have 2x plus 3 over x plus 3. And those will cancel out, and we're just left with 2, but x can't equal 3. I'll only do one of these examples, and so I'll do example A. Now, in this case, we have different monomial denominators. I have 3p and I have 7p. And so I want to find a common denominator between the two of these. And the common denominator I can find here is 21p. So if I were to multiply everything here by 7 and everything here by 3, I'm going to end up with 21 over, 7 times 5 is 35 over 21p. And I'm going to end up with, so plus 2 times 3 is 6 over 21p, or 35 plus 6 over 21p, which results in 41 over 21p, such that p can't equal 0. Last, we're going to look at an example where I have the addition and subtraction with different monomial binomial denominators. And so these ones can be a little bit tricky because we have to find a common denominator between 2x and x minus 4. Now, the common denominator between these two is actually going to be the product of the denominators themselves. And so 2x and x minus 4, that is going to be their common denominator. So everything here I want to multiply by x minus 4, and everything here I want to multiply by 2x. When I do that, I'm going to be left with x minus 4, x minus 9 over 2x times x minus 4 plus 3x times 2x all over 2x times x minus 4. Here we can simplify. So if I expand my binomials, I'll be left with x squared minus 13x plus 36 plus 6x squared, and all of that over 2x x minus 4. And simplifying again, x squared plus 6x gives me 7x squared minus 13x plus 36 all over 2x times x minus 4. And I can't simplify either of these anymore, so I can just state my non-permissible values, where x can't equal 0, 0, or positive 4.